Okay, so this video is helping people who are still struggling with Project 2, still have no idea where to go. I'm making this video so that this applies to both sections, so I don't have to repeat the same thing for 3 hours. And my throat is already hurting from yelling too much during class, so thinking of taking it easy today. So if you look at this project, you got to think about how we did things in class, right? We did things when we have a new problem that involves object and classes. We identify the objects in there. We identify the numerical objects that are in the numerical relationship between objects, and then also we identify the actions of the object. So the project already tells you what objects there are involved. There's the feature class, sample class, and dataset class. So we're going to have feature, sample, and dataset. And oops, where is it there? So what do they do? Well, even though those objects need to support all those following processes, but here's really what's sample, feature, and dataset is. So dataset, so sample is just simply each row in your file. And then a feature is basically just a column of each one of your file. So immediately you should know dataset class should have many samples and should have many features, right? So, oh wait, no, that's not it. So we have dataset class, sample, it's not letting me draw, and feature, right? Let me just delete these things. And then for the data set between samples, that's going to be 1, 2, n. This data set between features, that's going to be also 1, 2, n. And what's the relationship between features and samples? Well, that doesn't seem like everything, because samples is one row and feature is one column. So they overlap one value, right? Like this sample and this feature overlap this value, but nothing else overlaps. So sample feature really doesn't contain each other. It's just that one value that's overlapping. So there's really nothing in between those. And all right, so what are the actions? Well, actions seems like those objects need to support the following pre-processing, right? So these are going to be some of the actions that we have to consider. So method that calculate min of each feature. Well, that sounds like features job. Calculate mean, and then of course mean, variance, and standard deviation. Right? Those are all features job. And then find and then missing data. If one data field has no value, then it's called missing data. So either field with 0 or the mean of the feature. So once you see this mean of the feature, you should know, okay, this is also something that the feature does, right? If it's missing. Or it might be something the sample does if you're filling with the value 0. Either way, right? But from what we implemented before, so the missing data can be both feature for sample. When we implement the sample before, we did it in the sample class. Oh, where's everything? Oh, there. Okay. So these are the four methods. Seems like three of them should be feature related, and one of them can either be feature or sample. And then outlier, what is outlier? Outlier for each feature. So that's also going to be each feature's action. Feature mean, feature standard deviation. So that is definitely going to feature. So this is going to be outliers. What else? What else needs to do? Okay, so we're done with pre-processing. Now we move on to machine learning. For new sample obtained, calculate its Euclidean distance to all samples within training.csv. Sort the obtained. So this is basically how to do the prediction. Sort the obtained distance, look at the closest samples, label your new sample, right? So that's the whole predicting process. Let's break down the tasks in here. So first one, for any new sample, calculate its Euclidean distance to all samples with training.csv. So you can do that. So who's gonna perform the action? You can let the sample calculate distance, or you can let the data set calculate the distance. Either way, right? It's not very clear. It's not very clear which one should do it. But sort the obtained distance, this is definitely needs to be in the data set. Right? So, because this is going to sort all of the distance. Each sample is going to deal with its own thing, right? Its own distance to other samples, but it won't be able to tell what's going to happen for all of the samples. So this is definitely a data set thing. And then look at the closest samples, you can decide. So this is after the sorting. This you can decide the closest top 3 samples. So that sounds like a data set thing, right? Because it's dealing with more than one sample. Again, sample is only going to deal with its own thing. It only look at itself, whereas the data set has an overlook view. So if you're dealing with more than one sample, then that's a data set action. Look at top 3. And then label your new sample as the majority. So look at the top 3 and then find the majority. And all of the above, right? The distance, the sort distance, look at the top 3, find the majority. These are actually in the prediction process. So that's all the actions. And then after that, there's the evaluation, import test.cfc, use your algorithm, implement above code. And then basically what they're saying is we're going to take each sample of the test CSV, run it through our whole process, get the label, get the predicted label, and then use the predicted label to compare with the true label in test.csv. So basically, it's like this. So let's say these are your test.csv samples, right? And these are your training.csv samples. So it has a lot more in training than in testing. And then what are you doing? You're basically calculating distance between this, between each samples. right? Between each samples in the training, in the testing and the training, and there might be too many lines. There we go. I think this is, yeah, that's enough lines. So you take one sample, you calculate the distance, and then you find the top three, you make a prediction, right? So this now has a prediction value after we go through the whole process. So that might be Setosa. And this might be, let's say Setosa again. And this might be versicolor. So that's your predicted label. And then after that, you're looking at with a new label. So new label, this might be, the real label. In the testing.csv, the real label, this might be Setosa. This might be versicolor. And this might also be versicolor. So then you compare your prediction with the training, with the testing. So Setosa, you got that right. Setosa, you got that wrong. versicolor, you got that right. So you got 2 out of 3 right. So you were 66% right. That's your accuracy. So that's basically what they're doing. If you can predict a single sample over here, then this task is pretty easy, right? Because you just import each row, transform each row to samples, which you did with the training.csv. So you perform the same thing, you transform each row to samples, and then you predict each one of the samples. And then you see if the label you get is the same as in the file. So as soon as you figure out how to predict one sample, this is very easy. So let's focus on here, how to predict this one sample. So after we figure out all the actions, now we can pretty much code this thing up, right? Oh, one more thing with the data set. Data set will have to also be able to import data, right? That's the most important part. That didn't say it here, does it? Yeah, it didn't say it here, but we have to somehow read the data somewhere. Like I might not have to be in data set. It can be in main class or somewhere else. All right, so let's code this out. So one thing I recommend is using the sample class that we did together in the classroom. So sample.java, right? We did this together in the class, and then so that's in that's in week 10 module. It's also for the section 2, it's also in the week 10 module. So you definitely want to start with this. So let's just copy things over. So I want to create a sample class. I want to create a feature class. I want to create a dataset class, right? So in sample, this is what we did. Oh, whoa. Oh yeah, it has a bunch of comments. That's why. Okay, well, let me Let me download this. Sample.java and open this. There we go. So the sample.java we already did a lot. Like we did the constructor, right? The constructor takes double value, constructor to take string token, and then we did all the Euclidean distance together. So now we can implement feature class. So feature class, obviously what we need, we're gonna need, let's look at this picture, right? Feature has nothing to do with sample. So we're just gonna need an array list of values. Right, so it's basically the column of your data set. And then in here, what do we have to do? Well, first of all, we need to have a getter and setter for those, right? Getter, setter, all right. And then after that, what are the actions? We got mean, variance, standard deviation, missing outliers. So so I'm not gonna code these because those are just simple math, right? This one is just sum all in column and then divide by call aside. That's pretty much what it is. Variance is sum all, what are we summing? We're summing the call dot get I minus mean, and then you want to square that. Right? So the sum of all of that divided by call the sides minus 1. And then the standard deviation is just the square root of variance. So we're not gonna do that. For now, I'm just gonna return 0. But you actually have to code this out. So don't just return 0. Now after that, what else do we need? We need to do, maybe do the missing, maybe do the outlier. Well, it turns out if you look at the sample class we did together, this constructor sample string token already take care of the missing value, right? Missing value means there's an empty spot in your data. So an empty spot means that data length is 0. So if that data length is 0, then there's a missing data. So we're gonna set it to 0. So that is already taken care of in sample. So we don't have to do that. So now we just need to figure out outliers. And there's a definition of the outlier. Outlier is just feature mean plus 2 times feature standard deviation. If your value is greater than that, then you're outlier value. And then the outlier value is going to be feature mean is minus or smaller than equal to feature mean minus feature standard deviation. So that's just super simple, right? So for all values, right? So what's going to happen here is just for all, for every value in call, if any of this thing holds, right, greater than equals to this, or smaller than equals to this, then it's an outlier, right? That's just a simple for loop and an if statement. But then the question is, what are we doing with this outlier? Well, once you find the outlier, you can decide whether to keep the sample with the outlier value in machine training or throw it away, since the outlier value might be an error. So you can decide if you want to keep it or throwing it. When I did it, I throw it away. But since if you guys haven't got to here, it might be too late. So you might just want to keep it. Let's be honest. So you can just find out all the outliers, and then just say, oh, I just want to keep everything. That also works. For now, because I mean, this is already kind of late. All right, so we did that. And so we did just all the samples. So now all we need to do is the data set. So we can either decide whether we want to do the data set import in the data set or outside of the data set. It really doesn't matter. But what does data set have? Data set have many samples, many features. So this is just going to be samples. And then since we only have 4 features, right? I'm just going to make an array instead of array list because we know exactly how many features there are. So if you want to do the data import inside the data set, then you need to create a function called data import. And then what's going to happen in this data import? In this data import, you're going to have to do file equals to, well, let me just copy paste. Just copy paste things over. So this is how I did the import data. Basically, I pass in the file name, and then down here for each of the features, I create a new feature. See, here's the thing. I create an array of features, right? Now that array is new. But each element of this array, meaning each one of the features, that is still null. So when you import the data, you have to go through the array, and for each element, you have to make new features. Otherwise, they're just gonna null. It's just gonna crash your code. So why is this not happy here? Expression expected. Oh, this is new array list. Wait, does that mean this is wrong? Oh, no, I didn't even copy paste from there. Okay. Yeah, so we are gonna initialize each one of the features, and then this is just standard file input, right? File f equals new file name, scanner scan equals new scanner f, and then while file has something, you read the line, you split them into tokens, and then since our sample, if you pay attention in class, have this constructor that takes the string array. So we can just simply do sample s equals new sample token. That's how we got the sample now. So we add this sample to our samples. And then for each one of the feature, so what is each sample? Each sample we have 4 values, A, B, C, D, and then the label, ours. So A belongs to feature 0, right? B belongs to feature 1, and so on and so forth, right? Because A is the first column, B is the second column, C is the third column, D is the fourth column. So since we're reading each row, then we're really adding one by one the column value to the feature. And that's exactly what we're doing here. We're using the s.get values. So we get all the numerical values from the s. That gives us an array of 4 ABCDs. And then the feature value will just be the ith, right? 0 is A, 1 is B, 2 is D, 3 is D. So we get those values in the feature values, and then we get the corresponding features at position I, and we simply just add to the feature. Well, our feature actually, we didn't implement add, but we implemented the get call. So we're just gonna do that. Now, do we need to do set call again? Do we need to do this after we add it to this? Because it seems like we get the array list call out of that, and then we add some value to it. So we need to like kind of update the original feature, right? Do we need to do this? Well, since we learned the object references, then if you look at the feature, we're just simply return a reference of this variable with the return call, right? So this call points to that. That's why this call is going to point to the variable inside the feature. So when you update this reference, the feature call already updates because they all point to the same address in memory. So we don't have to do the feature set call after this happens. All right, we're not going to consider outlier for now. So delete that. So we did what? We did the import data. Now we have to do the distance, right? Distance is just the Euclidean distance that's mentioned in here. So that's the formula. So you can do, okay, well, in the sample class, we already did the distance, but you can also do it in the, data set. So in sample, if you look at that, what's the distance? Sample other, right? Is this sample distance with another sample. So there's going to be 2 samples involved. So if you implement in data set, you're going to need 2 samples. And then in the data samples, how do you get the P1, P2, P3, Q1, Q2, Q3? Well, that is just your values, right? So you can just do double V1 equals to S1 dot get values, double V2 equals to S2 dot get values. So inside V1, you get 4 numbers, A, B, C, D. That's you P1, P2, P3, P4. In V2, so V1 has P1, P2, P3, P4. V2 has P1, Q1, Q2, Q3, Q4. So then you can calculate distance based on formula, right? That's basically here. And then you want to return the distance. So this is what you want to do if you do the distance in dataset. And then we have to sort all the distances. So we're going to do something like, so what are all the distances? That's probably going to be in an array. Actually, probably going to be in an array list, right? Because our sample is in array list, because we don't know the size of it. So we probably want to do list double distance. So this is just normal sort, right? And then if distance dot get I is smaller than distance dot get j, well, let's swap them. So double temp equals to distance dot get I distance dot get j, and then distance dot set j temp, right? That's just basic sorting. And then we want to look at the top 3 of the samples, right? The top 3 closest samples, and then find the majority. So after we sort the distance, we're gonna look at the top 3 things. So how do we do that? How do we look at the top 3 things? So let's look at the, let's call this top 3 majority, right? So why are we doing the top 3 majority? Because we want to find the majority of label, right? We want to find the majority of label, so it's gonna return some label here. So that means we might want to return something, right? We might want to return a string. Or we might not need to. We'll see. We'll see. Since the description is not very clear here, so let's just keep it void and then see what we can do. All right, so the top 3 majority is gonna need something from this sorted distance, right? Because how do we gonna find the top 3 majority? This distance is every single distance from our sample, the sample what we're trying to predict to everything that we put in up here, right? So now what can we do? Let's think about what we can do. And so we're gonna need to get a sample somewhere, right? I think the description is very unclear. So distance between training and sample and the one that's being predicted. This is all distances we're calculating. And then we're gonna sort those distance, and then we're gonna look at the top 3 closest samples. Those are the 3 actions. So we did sort distance, we calculate distance between 2 samples, but we didn't do all distance. So let's do it, let's make a thing that called all distance. And what does all distance do? All distance is going to be between training and the predicted sample, right? So how are we going to get the predicted sample? Well, let's just assume somebody get it somewhere. We don't know how, but somehow we get the predicted sample, right? Because it's not very clear how we're getting it. So here we can just do array list double distance equals to new array list double. And for I equals 0, I smaller than samples dot size, right? Samples is everything in your training.csv. And then we can either use this distance or the one we implement the samples that distance, right? We can do double D equals to either S dot Euclidean distance samples dot get I, or we can do double D equals to what do we call it? Distance. S and samples dot get. Right, this one's using the sample distance, this one's using the dataset distance. Either one works. Call this D1, D2, and then after that, we're going to add it to distance. So we get all the distances, that's a function, and then we need to sort all the distances, and then we need to find the top 3 majority when we are predicting it. And okay, so but if you look at this, there is still like the information is still not flowing, even though we need to use those 3, calculate all distance. So this comes first, calculate all distances, and then we sort the distances, and then we're going to look at the top 3. So if you look at this, all right, I have the distance array here. I calculated it. All right, that's it. That's done. Cool. And then sort distance, we are going to take one distance, and we're going to sort it. Okay, cool. And then somehow we need to get this sorted distance to the top 3 majority, right? Basically, we need to somehow get this in here and somehow get this sorted distance again into here. And then we still have no idea how to implement this yet. But right now, That's our concern, right? Because it looks like this is not going into here because we create the distance in here, we add everything, yeah, cool. But then after that, it's forgotten, right? After this function is done, it's done. Like we don't know how to get this thing into that. Well, there are two things that you can do. One is whenever you need to pass information around classes, you can always just make a variable, right? There's nothing that is stopping you from creating new things in your class. If you think you need it, then you need it. So this distance is going to go here. And then since we have this as a class variables now, we don't need that to be passed in anymore, right? Because those are all just be the class variable. So now the distances we created here get sorted in here. And now we'll look at the top three, majority. And then because the distance is there, then we can also get the sorted distance here. All right, so now you move down to top three, majority, and then you probably are thinking, okay, for int I equals to 0, I smaller than 3, I plus plus, right? And then you're maybe thinking like double D equals to distance dot get I, something like that. But then you're kind of stuck. Okay, what does that mean? Distance dot get I, that gives me a distance, but didn't give me any of the labels. Right? I only got a double number and that didn't tell me anything. So then you think, okay, maybe instead of that, where is label? Label is inside sample. So maybe I want to do this, sample as.get I. And then maybe like string label equals temp dot get label, right? You might be thinking about doing that. But then you realize, wait, we just sorted the distance, right? That the top three, if we do this, we're getting the top three from the samples. That's not necessarily the top three shortest distance. So we realize there's a disconnect. When we are calculating only the distance, we forgot what sample that is associated with. So if only there's something that can associate your distance with the sample, right? Only if those two are in a neat package that put them together. Well, we have that package. We can create that package now. What is it called? It's called class, right? Class is a package of relevant information. So nobody's stopping you from creating a new class. In here, we're going to do sample from, sample to, and then double distance. I'm going to make those public for now, just to save some time. But you really should make it private, right? Nobody is stopping. Nobody is standing there with a gun in your head saying, don't create any new classes for project 2, right? Nobody's doing that. So you're afraid to do something like this. So then everything's changed, right? Distance equals new array list. Now instead of double, because we know if we only do double, we lose the association with the sample. So this is just going to be distance and sample. And then we did the D1, D2. So what should be added to the distance? It's distance and sample, DAS equals new distance and sample, right? And DAS dot from is S, is a 2 is sample, samples dot get I, DAS dot distance equals to D1. Now, how do we do sort? It's no longer distance.getI, but distance.getI dot distance, right? Because distance get I get the distance and sample. And in there, we have to get the actual distance in the distance and sample. And then here's obviously not double, it's going to be distance and sample. And then now everything's fixed. So now when we are doing the top 3 majority, you can just do string label equals to distance dot get I dot 2, right? Because 2 is where we store. So the distance is from S to this. So 2 is where the label is at. Or actually, let me just make this simpler. Let me just make this string label, right? Why not? Why not just do that? Why do we want to jump all those hoops? There, that's straightforward. The get I dot label, right? Done, boom. So now you have to find the top 3 majority, right? That means you need to find how many setosa there are, find how many versicolor there are, and then find how many virginica, and then just get the label with the largest number, right? Now we're looking for the largest number of 3 numbers. That's like the week 2 assignment. So if you're not sure how to do that, make sure you go back to week 2 or week 3. So basically, so in order to find how many setosa, obviously we're not going to do here, right? This is we're just getting the label here. So instead of doing that, maybe you need to do some counter things, something like that. So that's the top 3 majority. So what are we going to do when we're predicting, right? We still don't have the main class yet. Well, let's get the main class. So in main class, what are we doing in main class? Why is there an error here? Something says it's wrong here, but I can't. Okay, it's gone. All right. So in main class, of course, we're going to create a data set. DS equals new data set. And then since we And then we have to import the data, right? Since we already create the import data, we can just do ts.import data and give a file name. So it's going to be training.csv. So now you have to predict one sample, right? How do you predict one sample? Let's say sample equals to 1.0, 2.0, 1.0, 2.0, 3.0, 4.0. Let's say that's our sample there. And we're trying to find the label for this sample. All right, fine. So what are the 3 steps to calculate the label sample? We need to calculate the O distance, and then we need to sort them, and then we need to find the top 3 majority, right? All right, so let's do that. O distance takes a sample S. So how do we get a sample S out of this? Well, we can just do string token equal to sample dot split. Right? Whoa, what am I doing? Split. And then if you look at this token, it has 4 values. But when we're doing the sample, well, let's just do this. Let's just do string token equals to this. If you look at our samples, when we are doing the row token, we need 5. We need 5 things in row token. So, well, let's just do this for now. So sample S equals a new sample token. And then after you run the code, to find out s.values, get values is actually empty. I'm gonna try what this deep2 string is, because Eclipse really wants me to call this deep2 string. Yeah, it's not even right. So you run this code, you realize, oh, there's a bunch of problems. Well, first of all, it's file not found. So that's a problem. Oh yeah, because the training is not imported in here. There we go. So instead of training.cfc, now I have training. So when I run this, oh, it's a bunch of zeros. What's going on? So you look at the sample string, you realize, oh, the row token length must be 5. All right, fine. How do I make this 5? Let's just add an empty comma there and give a fake label, because we're going to predict this anyway. So it doesn't matter what this is, we're going to do the prediction. So now we run this. Okay, all the values are in there. Cool. So what are the 3 steps of prediction? ds dot O distance, right? Sample. String. Oh, wait, no, it's not sample, it's S. And then ds dot sort, right? And then ds dot top 3 majority. So that's the one label that you need to get. So since this one gets a label, you're going to do string s dot label or set label is this. So you do system.out.println your label is and then you realize, oh, there's something wrong. What's going on? Method set label string in the type sample is not applicable for the argument void. What do you mean void? So you go back here, you realize, oh, that's a void. So I'm actually not getting any strings out of this, right? Like I might get the label in here. Like after all the counting, I might be like string majority equals to like some label. After I figure this out, but this information is lost again, right? It didn't flow from here to the one we're predicting. So how do you prevent this information to be lost? Well, one way is just do this. Well, I'm gonna make this public for now, again, to save some time. You can just do current predicted label is this. So what this is gonna be, after you call the DS3 top majority, you can just do s.label or set label. It's gonna be ds.current predicted label, right? Now information flow back. But this seems like a bad idea. Why is that? Because dataset controls all the dataset stuff. So this variable doesn't really fit here because the predicted label belongs to the sample. Belongs to the sample we're trying to predict, right? So it doesn't really fit in this whole dataset like class. Remember, you want to keep things relevant of the class in the same class. So what are other ways to get this out of your function? Well, how about just return it, string. Again, this label is gonna be the label that you find here. It's not just string label, all right? Make sure you pay attention. Don't jump to this moment in the video, be like, oh, just return label. Okay, I'm done. But no, you have to actually find the label here. So after that, we no longer need this. This DS top 3 majority is going to return the label that we need. So this label is DS top 3 majority, set label is just label. And then we're done. And then for part 3, so this is part 2, right? Part 3 is basically you're just reading testing.csv. And then for each row, you want to create a sample and then do the prediction process like above. Get the predicted label. But then the thing is, once you get the predicted label, we have to compare, right? We have to compare with the original label. So don't do s.set label. Because then you forget, once you set label, you overwrite your original label. So you kind of want to just stop here. Once you get the label, so don't do that, but compare the label you get with s.get label. And if they're the same, then you got one correct. If they're wrong, then you got one wrong. And then The accuracy is basically the number of correct times divided by the entire testing CSV, right? It's the number of times you got it right versus all the times you tried. That's the accuracy. So basically, once you get the predicted label, don't be like up top, like, oh, let's set the label with the sample. Well, we can do this because we put a placeholder label here. But if you do it down here, you're gonna overwrite the true label from testing.csv. So don't do that. But you wanna compare the label you get here with the true label from s.getLabel. So that is it. That's pretty much project 2. I'm trying to do it in kind of like in your perspective, right? Going step by step and how you might run into problems, like passing around informations. Sometimes if you want to pass around information, well, you can just create variables. If you need more information to bundle together, I'll just make a helper class, right? There's nobody holding a gun to stop you from doing that. So just do that. Make life easier. And then once you get more familiar with the object-oriented programming, you can plan ahead. Like you might not need this because you plan ahead. You might not need this distance array to be here because you plan ahead. But that's probably going to be when you're a junior or senior, when you have more experience under your belt. So don't worry about it now. If you feel like, oh, I need some more information here or some more things that help me, just create it. So, all right, so that will be it. I will post this on YouTube and put it on Canvas.